Hi, this is Sean Moran with ACC GIS, and our topic today is transforming data, something we do all the time as GIS professionals. But we also transform data in our everyday lives. For example, transforming speech. If you use a virtual assistant like Google's Assistant or Siri or Amazon Alexis, then you are transforming your speech into data. Now, if we look at the timeline for the development of this technology, it's taking a long time, even though it's really accelerated in the past few years. You have to go back to the 17 and 1800s when they were developing the technology to record voice, and then all the way to 1950s when Bell Labs released Audrey, which was able of recording 90% accuracy the spoken word of its inventor. Now, it couldn't do anybody else. It was about 100 words, I think, and it couldn't do anybody else because there were variations in the way that people said things. Now, fast forward another 10 years, and IBM developed Shoebox, which allows people to train the software to interpret their voice to say 16 different English words, or to actually to convert 16 different English words to text. Then we had some more advancements over time, but it wasn't until 1997 that we were able to access that technology as kind of the everyday user. A piece of software came out called Dragon Naturally Speaking, and you could get it for Windows-based machines, and you could actually just speak in your natural voice to the software, and it would convert your voice into text. And it had a pretty good accuracy rate, like maybe like 90%, which we expect a lot higher today, but was really amazing at the time. And then, of course, fast forward to today, and speech transformation is integrated into our everyday lives. By the end of this topic, you'll be able to describe how data functions are used to transform data. You'll be able to differentiate between concatenate and parse text functions, functions we use every day as professionals. You'll be able to describe the order of operations for mathematical functions and spreadsheets. You'll be able to explain how logical functions can be used to test value expressions. Last, you'll use spreadsheets to transform data. Data transformation is simply the process of converting data from one format or structure into another, taking data from source to target. Some of the processes involved with doing that include extracting data from a source, converting that into the final format or structure necessary to support our analysis or process. And this often involves a mixture of manual and automated steps. Rarely do we just get to press a single button and it works. We typically have to set up the data a little bit, press a few buttons, and then maybe even process the data after that manually. So why do we transform data? One reason is to make the source data compatible with the target data. Another is to convert the source data to a target system. Maybe we have a piece of software that requires a different format of data, and so we'll convert the data over to the new format so we can use it in the target system. Last, we'll often combine source data with target data. So you'll have source data in one format, target data in another, and you need to integrate that data. So you'll combine them into a common format and integrate them that way. Some examples of data transformation include cleaning and aggregating pedestrian accident facilities for Austin metro area. You might get that data, for example, from Austin Police Department, but the Austin metro area also includes, for example, Round Rock PD, Travis County Sheriff's Office, Pflugerville PD, and so you would have to contact these different organizations, ask for this data, you would get it, it would come in different formats, and then you would have to clean that data up and aggregate it into a single file so that you could produce your analysis for the entire Austin metro area. Another example is scraping or copying a website table with population by county and pasting it into a spreadsheet. Seems like a pretty simple process, but when you do that, it brings on a lot of the formatting that is on the web page. Maybe the data is not organized correctly on the spreadsheet, and so you have to manually clean that data up. The last example might be updating a food trailer map with revised locations and new trailers. So depending on how often you update the food trailer map, let's say once a month, you might have to go out, collect that data, transform it so that it can be integrated into the final system, maybe an interactive map that people can access via an app. That would be an example of data transformation. Some basic data transformations include cleaning, deduplication, format revision, and key restructuring. Cleaning is when you're basically doing just that. You're cleaning up the data so that it works for whatever process or analysis you're getting ready to perform. A common example is mapping null to zero. A lot of times when you collect data, there are values that are null. It means there's nothing there. And sometimes, depending on the software or the process you're doing, they cannot handle those null values. So you need to search out, find all those null values and convert them to zero. Sometimes you're going the other way. Sometimes the cell values are all showing zero, but you don't really have any data there, and you don't want to show zero like you collected data, and so you convert those zeros to null. So it just depends on what you're doing. Maybe you're converting a value from one expression to another. So for example, male and female to M and F, or maybe it's something like standardizing the date format. You have a bunch of different date formats, some leading with the year, some leading with the month and the day, and you need to have them all in the same date format so that you can query them. That would be an example of a basic data transformation where you're cleaning the data. Deduplication is something we do a lot. Often you'll have duplicate records, especially in really large data sets. And it's one thing if you have duplicate records in 10 or 50 record data set, you can go through manually record by record and you can find those duplicates and delete them. But what if you have 10,000 or a million records? Suddenly it becomes an overwhelming task. Well, you can use software to go through and find and remove all the duplicate records. That's something we do a lot. Format revision, where you're converting from one format to another. So for example, a character set conversion, maybe you have some data in which you have degrees, minutes, seconds, and you're utilizing the little symbol for degree, which is a little circle that's in superscript, and you want to convert it to the letters DEG so it supports whatever your process is. That would be an example of character set conversion. Or maybe unit of measure conversion. You're going from Celsius to Fahrenheit or Fahrenheit to Celsius, or it could be, for example, a date time conversion. The last basic type of data transformation we'll discuss is key restructuring. Key restructuring is important and something we do often because we in GIS are often taking some geography, like zip codes, for example, and some tabular data set, like data median household income, for example, by zip code, and then we need to link that data up, each feature in the zip codes with each record in the zip code table. And we need some type of field, common field that has a key that can allow us to link those up. And that key often must be in the same format and the values must be structured the same way. So we spend a little bit of time often looking at our data and maybe restructuring the key so it'll support some join between our features and records, and later on we can utilize that in our analysis. In addition to basic data transformations, there are a number of advanced data transformations as well, including derivation, where we're deriving new calculated values from existing data. This might be where you take the values in one field and utilize them to calculate the values in a new field. So for example, I might have a field that has square feet values, and I want to convert those to a new field that has acreage. We also group values into categories or ranges. So you might have a field that has values that range, for example, from 0 to 100, and you really just want to categorize them into low, medium, and high. So you take all the values that are 0 to 33, and you categorize them as low, 33 to 66 as medium, and 66 and up as high. That's an example of grouping. Filtering is where we select only certain rows and or columns. If you download data from the US Census, for example, there might be 150 different fields, but you're only interested in 3 or 4 fields. And so we'll use filtering to go and make sure that we're focused just on the data that's of interest to us. Joining and splitting, also known as concatenate and parse, is something we use almost every day. Joining is where you take the values in multiple fields and you join or concatenate them into a single value in a field. So for example, I might have addresses broken out by address number, address name, and address type. For example, 201, Main, and street. And I want to join or concatenate the values into a single field called address. And so I would concatenate those fields, and the value in the address field would just be 201 Main Street all combined together. Sometimes we're going the other direction. We're splitting or parsing out the data, and that's when we're splitting a single column into multiple columns. Utilizing the previous example, I might have an address field that has 201 Main Street, and I want to break it out to address number, address name, and address type. And so I parse or split the data to split those values out into multiple columns. We often use data transformations to validate or check the quality of data. The great thing about computers is it can handle a lot of data and it can provide and look at millions of records in seconds, which it might take somebody hours to do manually. And so we can utilize these processes to validate our data. Enriching is a newer transformation that you see where people are taking some existing data set and then enriching it with others to make it more valuable. An example in GIS might be I have a map layer that has zip codes, but I also want median household income. Uh, I want what their college education level is and what the value of their house is. And so I can use enriching functions to go to different source data sets and then combine that so that I can bring it all together in a single data set. Summarizing is where we're statistically describing the data. Again, if we have really, really large data sets that have a million records, it's really hard to tell one thing from another if you're just looking at individual records. And so we will summarize fields, for example, to find out what the overall average is, what the min value is, what the max value is, things like that. Aggregating is where we combine multiple data sources into a target data set. We do this every day in GIS where we're taking data from different geographic regions, for example, or different entities, and we're aggregating that into a single target data set or tabular model that we can utilize. Lastly, integrating, where we reconcile different data names and values for the same data element. An example of that might be I have a bunch of address data and it has boulevard sometimes spelled out and sometimes it has it as BLVD. And I need to make sure that all the data is standardized so it supports whatever my analysis is.